Hi, welcome to a new session of Circuits and Networks. In today's class 17 under two-port networks, we are going to see a different problem which is involved in this fashion, which is shown in this particular figure as 1 ohm, 3 ohms and 2, that is a T network, and parallel to 1 and 3, you can see 4 ohms is taken. So whether we have to convert into star to delta, delta to star, that is a complicated process. So without converting that, how to solve this problem with the normal approach we're going to see in today's session. So here we know what about the two-port network parameters, that is Z parameters, Y, ABCD parameters and H parameters given by equation 1 to 8. Now once you are done with Z parameters, you can easily convert them into other parameters like admittance parameters, ABCD parameters, H parameters, which is given by this formula. Or if at all you have derived the Y parameters, you can get the Z parameters, ABCD parameters and H parameters given by this formula. Now once we are done with the formula, let us go with the problem where you can see we need to find out the Z parameters. So the standard equation is given by 1 and 2 equation. So when you are going to get the solution with actual approach, which is known as method 1, where in step 1 we are going to see that the open circuit port 22 dash, that is, this is how we have selected the port 22 dash, and we are going to open circuit it. Once you open circuit this, I2 becomes 0, but V2 is present. How V2 is present? It is present across 3 ohms and 2 ohms. So from the standard equation 1 and 2, you can derive equation 3 and 4 like this. Once I2 is made equal to 0, equation 3 and equation 4 are obtained. Now when you open circuit the port 22 dash, this is how the circuit looks like. In fact, you can see that 3 and 4 actually are in series. So this becomes 7 and 7 is parallel to 1. So the parallel combination will give you the value as 7 by 8 ohms, that is in series with 2. With simple KVL approach, you can get the value of V1, which is equal to 23 by 8 I1. Hence, Z11 is obtained as equation 5. Then reframing the circuit as the original circuit in this fashion, which is given here. What is our interest? To know the value of current which is flowing in 3 ohms. In fact, the same current is flowing in 4 ohms. So let us treat the current which is flowing in 7 ohms, which is flowing in 4 ohms and 3 ohms in series as I1 dash. So I1 dash would be flowing across 4 and 3 in this fashion. In fact, when the current is flown through resistor, the potential developed across 4 and 3, it would be in this fashion. And actual current which is flowing in 2 ohms, that is I1, will develop a potential drop across 2 ohms, which is shown by this sign convention. And we know that V2 is a measurement made across port 2 dash. Now apply KVL in anti-clockwise direction to this open port. So we are going to get minus V2 plus 3 I1 dash plus 2 I1 equal to 0. Now what is this I1 dash? You can look into this circuit. I1 dash is nothing but we are applying here current division rule. For 7, 1 is the opposite. So 1 into total current I1 divided by 1 plus 7 will give you the value of I1 dash as 1 by 8 I1. Now substitute this current in this equation. I'm going to get V2 is equal to 19 I1 by 8. In fact, Z2N is obtained to be 19 by 8 ohms, and this we are treating as equation 6. Now the same approach we are going to go with the step 2 by open circuiting port 11 dash. When port 11 dash is open circuited, this 1 and 4 becomes in series and this 5 and 3 becomes in parallel, and the net combination will be in series with 2. Hence you're going to get the value of V2 in terms of I2 as 31 by 8. So Z22 value is nothing but that is 31 by 8 ohms. Let us treat this equation as 9, and then we are going to inspect the current which is flowing in 5 ohms. In fact, the current which is flowing in 4 in series is 1 ohm, that is nothing but 3 by 8 I2. This we have obtained with the help of current division rule. Now once this I2 dash starts flowing through 4 and 1, it develops the potential across 4 and 1, which is shown this by this sign convention. And already we know that V1 is a measurement across port 1 dash. With this, we are going to apply KVL into this open circuit, and we are going to get the value of V1, which is equal to 19 by 8 I2. In fact, Z12 is nothing but 19 by 8 ohms, and equation 10 is framed. Now with this 5, 6, 9, 10, we are going to get the Z parameters, which is nothing but 23 by 8, 19 by 8, 19 by 8, and 31 by 8 ohms. Now once we are done with the Z parameters, let us calculate the Y parameters. For this, I am taking the method as method 2, and this method is known as equation substitution method. You can see the standard equation 1 and 2, which is already framed, and I am applying KVL for I1 in clockwise, I2 in anti-clockwise, and I3 in again clockwise. So when I'm going to apply KVL, I'm going to get the value of equation 3 in terms of V1, I1, I2, and I3, which is shown by equation 3. Similarly, equation 4, we are framing the I1, I2, and I3 in terms of V2. And when I'm going to apply the KVL in loop 3, I'm going to get the value of I3, which is nothing but equal to I1 by 8 minus 3I2 by 8, and this is treated as equation 6. Now substitute equation 6 in equation 3 and equation 4. We are going to get the standard equation when you can compare with the equation 1 and 2, and that is nothing but the Z parameters, which is obtained as the same result with method 1. So once we are done with the Z parameters, we can get the value of Y parameters, which is obtained to be 31 by 44 minus 19 by 44 minus 19 by 44 and 23 by 44 mhos. So this is how we are going to calculate the admittance parameters from impedance parameters under method 2. So this method is known as equation substitution method. Now let us go with the calculation of ABCD parameters. So method 3, I am treating this method as parallel circuit division method. What we have to do, we have to take this circuit and we have to divide it into two halves. So you can see I can take circuit 1 and circuit 2 like this. That is nothing but a T network and a network with 4 ohms on the both sides open circuit. So circuit 2 and circuit 2 are framed. In circuit 1 and circuit 2, you can reframe to be in this fashion, that is circuit 1 and circuit 2 is nothing but the simple configuration. So let us go with the circuit 1 approach. You can easily calculate the Z parameters for T network. How? The Z11 value will be nothing but equivalent to 2 plus 1, that is 3, and Z22 will be equivalent to 2 plus 3, that is 5. And between port 1 and port 2, 2 is the intermediate for T network, so it is nothing but 2, 2. So this we are treating as Z1. With this I can get the value of Y1, which is equivalent to 5 by 11 minus 2 by 11 minus 2 by 11 and 3 by 11. This I am treating as equation 1 under method 3. Then I am taking circuit 2. For this circuit 2, if at all you take the Z parameters, you will get the value as 0. So what you have to do, you can convert this circuit into Y parameters. By how? By short circuiting the port 2. Port 2, when you short circuit that port, you are going to get the value of V2 equal to 0. But mind you, I2 is present. This I2 is present, and I can get the value of V1 and I1 with the help of this equation, that is nothing but I1 by V1 equal to 1 by 4. In fact, Y11 will be equal to 1 by 4. But I1 is also equivalent to minus I2, so I can get the value as minus 1 by 4 for Y21. Why this has happened? Because you can see here I1 is equivalent to minus I2. So we are done with Y11 and Y21. The value is 1 by 4 and minus 1 by 4. Since the circuit is same for Y12 and Y22, I am going to short circuit the port 1 and I'm going to get the value of Y22 and Y12, which is again equivalent to minus 1 by 4 and 1 by 4. This I am treating as equation 2. Hence, with these two circuits, I got the value of equation 1 and equation 2. I'm combining with addition and I'm going to get the value of Y parameters, which is obtained as 31 by 44 minus 19 by 44 again minus 19 by 44 and 23 by 44. This answer we already got with method 2. Now once you are getting the y parameters, you can obtain the z parameters, and the z parameters is obtained to be the same answer what we got with method 1 and method 2. So once we are done with z parameters, you can convert them into ABCD parameters with the standard equation shown by this ABCD equation. And with this, you're going to get the transmission line parameters or T parameters, which is obtained to be 23 by 19, 44 by 19, 8 by 19, and 31 by 19. So like that, you can calculate the Z parameters and Y parameters for the various arrangement of the resistors, which is shown in question 4 and question 5. For that, Z parameters answer is obtained, Y parameters answer is also obtained. You please comment in the chat box whether you are able to obtain the same solution or not. And that's all for today's class. Please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. Thank you.